Hey deserving students, Miss Ortiz here with another example on how to set up and solve an energy equation. These equations are taken from Apex Study 2.1.3. Here we go. The question is, if ball 1, mass of 3 grams, or 0.003 kilograms, is being held at a height of 1 meter above the ground, how does its PE compare with ball 2, mass of 20 grams, or 0.02 kilograms, held 0.1 meter above the ground? Let's think about our strategy. What is the question asking us? The question is asking us, how does its PE compare? So we have two different balls, ball 1 and ball 2, and the only thing we need to know about either of them is their PE, or their gravitational potential energy. So to figure out what I need for this, I have decided that I need my equation of potential energy, or gravitational potential energy, and I need it for ball 1 and for ball 2. Let's pull out the relevant information from this question. We know that the equation for gravitational potential energy is equal to mass times the force of gravity times the height. All right, I have that equation. Now I need to know what the mass is, and I need to know what the height is for both ball 1 and ball 2, because remember that G, the gravitational force of the Earth, is always equal to 9.8 meters per second squared. Okay, so the mass of ball 1 is going to be equal to kilograms. So this question has added one extra piece of steps, except for it does the work for you. Remember that whenever we're dealing with SI, we're always going to be using units of kilograms in our equations. So 0.003 kilograms is what we would translate 3 grams to. And then we know that the height is going to be 1 meter above the ground. The next thing we need to know is the same information for ball 2. Remember that G is going to be a constant of 9.8. So we only need to know the mass and the height of both balls. Well, the mass is going to be 20 grams, but we need to use kilograms. So it's going to be 0.02 kilograms. In some questions in the future, you might be asked to convert this kind of information, but that's not an issue right now. It's already told us that 20 grams and 0.02 kilograms are the same thing. The next thing we know is that this ball is held 0.1 meter above the ground. Alright, so now I have everything I need to know. I know that I need to use the equation for gravitational potential energy, and then I know that I need to use the mass of ball 1 as 0.03 kilograms, its height as 1 meter. And ball 2, mass of 0.02 kilograms, and then height of 0.1 meter. Now I need to calculate mass times the force of gravity times the height for both. I've done my strategy for both of these. Now I need to do the setup. Remember that the setup for a question means that I'm figuring out what numbers I need to plug in and where. So for each of these balls I need to know the mass and the height, which I already figured out in the previous slide. 0.003 kilograms and 1 meter for ball 1. And then for ball 2, it's 0.02 kilograms. The next thing I know is that gravity, or the force of gravity, is always going to be a constant 9.8 meters per second squared. I'm going to write that in for both. And then lastly, I know that the height of ball 1 was 1 meter. So I'm going to write that in. And the height of ball 2 was 0.1 meter. Okay, I have both of these set up. It looks like ball 2 is larger in mass, but much closer to the ground. And ball 1 is 0.03 003, so it's actually smaller than ball 2, but it's a lot farther from the ground than ball 2 is. If I was to try and make sense of these, I might say that, just kind of guessing, they might have very similar gravitational potential energy, because even though ball 2 is bigger than ball 1, it's not anywhere near as far from the ground. Let's do the math. Alright, I transferred everything over into something I can throw into my calculator. For ball 1, I have to do 0.003 times 9.8 times 1. And then for ball 2, I need to do 0.02 times 9.8 times 0.1. I'm going to do the math for both of those off screen. Alright, I figured out that the gravitational potential energy for ball 1 was equal to 0.029 joules, and the gravitational potential energy of ball 2 was 0.0196 joules. Ooh, almost forgot my units. I'll take a second to round these both up, because sometimes having smaller numbers in terms of digits makes things easier to look at. Alright, I rounded 1 up to 0.03 joules, and I rounded ball 2 up to 0.02 joules. Well, it looks like ball 1 is going to be my winner. Even though it's a lot smaller, it was farther from the ground. But remember how I said that I might expect both of these to be very similar, because even though one of them was much bigger, it was much closer to the ground? Well, there's my sense. Consummate S. I hope this was of help to you as you continue working on your practice problems. Thanks for watching, and I'll see you in the next one.